In this video, we're going to talk about pH. By the end of this video, you should understand how pH indicates relative acidity or basicity. You should be able to recognize how acids and bases differ in terms of relative concentrations of H+ and OH-. You should be able to calculate H+ concentration and OH- concentration from pH and from pOH, and vice versa. Let's start by taking a look at the pH scale. The pH scale is a continuum, so like any continuum, there's no hard and fast cutoffs. But generally speaking, strong acids have a pH of about 1. Strong bases have a pH of about 14. A pH of 7 represents a neutral solution. As you move from pH 7 to pH 1, solutions get more acidic. As you move from pH 7 to pH 14, solutions get more basic. Notice this chart uses the term alkaline. Alkaline is another word for basic. So where does the pH scale come from? Well, the pH scale comes from the relative concentrations of H+ and OH- in solution. So let's start by looking at water, which can act as an acid or a base. We have a term for solutions like this. They're called amphoteric. Amphoteric substances are substances that can act as an acid or a base. Water is the most common of these. We've already seen this example when we looked at the Brunstad-Lowry definition of acids and bases. Sometimes water acted as an acid, sometimes it acted as a base. If you think about water, you can see how this is possible. I've put two water molecules here. When they react with one another, you get H3O+, or H+ if you prefer, and OH-. Notice this is usually associated with acids, the H+, and this is associated with bases, the OH-. Since it has both, it can act as either. For pure water, the concentration of H3O+, or H+, will always equal the concentration of OH-, and that concentration is always 1.0 times 10 to the negative 7th. Pay particular attention to that 7 there. As you may recall, 7 represents a neutral pH. We can start to see the development of the pH scale right there. If we look at the KEQ for this process, it's actually called the KW since it's the K value for water. We take the concentration of H3O+ times the concentration of OH-, each of which, again, are 1.0 times 10 to the negative 7th, and you get 1.0 times 10 to the negative 14th. This is called the KW for water. So what does all this have to do with the pH scale? Well, it turns out that the ion product constant for water, or the KW, is also the value of the H+ concentration times the OH- concentration for any aqueous solution. So in other words, any aqueous solution will have at least a little bit of H+ or H3O+, and some OH-. It's the relative amounts of each of those things that determines if the substance is an acid or a base. So, if the H+ concentration is equal to the OH- concentration, it's a neutral solution. If the H+ concentration is greater than the OH- concentration, it's an acidic solution. And if the H+ concentration is less than the OH- concentration, it's a basic solution. And remember, in every case, H+ concentration is the same as H3O+ concentration. We could just talk about H+ concentration and OH- concentration for solutions, but because those numbers are really small, it becomes inconvenient. So instead we invented the pH scale. P is a mathematical operation that just means negative log. So you could take the P of anything and get the negative log of that thing. In this case, if we take the negative log of the H+ concentration, we get the pH. If we take the negative log of the OH- concentration, we get the pOH. And in every case, the pH plus the pOH will equal 14. Let's practice calculating some pHs for different solutions. In the first example, we want the pH of a solution with an H plus concentration of 1.0 times 10 to the negative third. Therefore, pH will equal the negative log of 1.0 times 10 to the negative third. In this case, that gives you a pH of 3. Make sure you know where the log button is on your calculator. If you have trouble finding that, I can help you with it tomorrow. In the next example, we're again asked for the pH, but this time we're given the OH minus concentration. The easiest way to deal with these problems is to start by finding the pOH, which in this case will be the negative log of 2.6 times 10 to the negative fourth. This equals 3.58. Since pH plus pOH always equals 14, if we subtract our pOH from 14, we'll be left with the pH, which in this case is 10.42. So here we have a base, whereas up here we had an acid. We can also calculate H plus and OH minus concentration from pH. Here we need to do the opposite of taking the negative log. The inverse operation of negative log is 10 to the negative, or 10 to the negative pH in these cases. So to calculate the H plus concentration in number 4, we're going to take 10 to the negative 2.5, which gives us 3.2 times 10 to the negative third molar H plus. In the next example, again, we're asked for OH minus concentration, but given pH. So again, we can take 14, subtract from that 4.7, and this will give us our pOH, which is 9.3. That's our pOH. From there, we can calculate the OH minus concentration by taking 10 to the negative 9.3, which is going to equal 5.01 times 10 to the negative 10th. So in summary, in order to get from the H plus concentration to the pH, we take the negative log of the H plus concentration. In order to get from pH to H plus concentration, we do 10 to the negative pH. Likewise for OH minus concentration. To pOH is negative log of the OH minus concentration, and pOH to OH minus concentration is 10 to the negative pOH. And finally, you can always get back and forth between pH and pOH by subtracting from 14. That brings us to the conclusion of this video. Let's quickly review our goals. First, we said that we were going to understand how pH indicates the relative acidity or basicity of a solution. So we said that substances with a pH less than 7 are acidic and greater than 7 are basic, with a pH of 7 representing a neutral solution. We also talked about how acids and bases differ in terms of H plus concentration. Acids have a higher H plus concentration than OH minus concentration, whereas bases have a lower H plus concentration than OH minus concentration. And again, neutral solutions have equal H plus and OH minus concentrations. We then learned to calculate H plus and OH minus concentration from pH and pOH. Remember that pH is the negative log of the H plus concentration. pOH is the negative log of the OH minus concentration. And H plus concentration is 10 to the negative pH, and OH minus concentration is 10 to the negative POH.